Hello, this is Josh Rolls. I was assigned problem 11 from section 2.1 for the third video presentation. So I'll go ahead and get started. The differential equation that we're looking at is y double prime minus y prime plus 2y is equal to 0, with the initial conditions of y of 0 is equal to 0 and y prime of 0 is equal to 5. And then the two solutions that we're going to be checking are e to the x times cosine of x and e to the x times sine of x. So first, with the first solution that we're going to be checking, we're going to want to derive it twice since this is a second order differential equation. So the first derivative is e to the x times cosine of x minus e to the x times sine of x, and then you derive it one more time, which is e to the x, or I guess after simplification you get negative 2e to the x times sine of x. That derivative is found just by using the product rule, basic derivative stuff there. And a very similar thing happens with the second general solution, which is e to the x times sine of x plus e to the x times cosine of x for the first derivative, and for the second derivative it's 2e to the x times cosine of x, and once again that's just using the product rule. Next I go through and I'll check and make sure both of them are solutions to the differential equation. So with the first one, I rewrote the equation in question, and then I'm going to go ahead and substitute where I see fit. So where I see y1 double prime, I'm going to use the second derivative of y1. So that's negative 2e to the x times sine of x. And then next I see minus 2y, y1 prime. So I'm going to put 2, and then in parentheses I'll have y1 prime. And then multiplied by 2 times just our regular solution that we're going to be checking is all equal to 0. And then after distributing that 2, you can see that everything's going to cancel out, and obviously 0 is equal to 0. And once again, a very similar thing happens for the second solution. So I have y2 double prime, which is equal to 2e to the x times cosine of x, minus 2, and then in parentheses our y2 prime, which is e to the x times sine of x plus e to the x times cosine of x, plus 2e to the x times sine of x is equal to 0. Once again, distribute that 2, everything cancel out, and equals 0. So the last thing we have to do is find the particular solution. So the general solution we now know is y to the x is equal to c1 times e to the x times cosine of x plus c2 times e to the x times sine of x, and then y prime of x is equal to c1 times e to the x times cosine x minus e to the x sine of x plus c to the c2 times e to the x sine of x plus e to the x cosine of x. So we know y of 0 from our initial condition is equal to 0, which is also equal to c1, and then y prime of 0 is equal to c2, and we know from the initial condition that's equal to 5. So after substituting that in, we get our particular solution is equal to 5 times e to the x times sine of x.